All right. We're doing 6.3, multiplying mixed numbers. And okay, what we're talking about is this. If I have the fraction, if I have the mixed number 5 1/3 and 2 times 2 1/4, okay, we don't have to have common denominators. That's the first thing. Okay, but we do have to change all mixed numbers or whole numbers to improper fractions. Okay, the way we do that, once again, to take 5 1/3 and make it an improper fraction. Okay, we're going to take 5 times 3. That's equal to 15. Then I'm going to take 15 and add the numerator 1 to it. That's equal to 16. Therefore, I have 16 over 3. So this fraction changes to 16 over 3 as an improper fraction. Then I have to do the same thing to 2 1/4. I'm going to take 2 times 4, which is equal to 8. Take 8 and add the numerator to it 1. That makes 9. And so that's 9 over 4. I'm going to stick it there. Okay, now, the next step, number 2, is talking about cross-canceling. Okay, cross-canceling is where you take and look at the top number of one fraction and the bottom number of the other fraction. And we check to see if there is a common factor between the two numbers. So is there a common factor between 9 and 3? And what is that? 3. So 3 goes into 3 one time. 3 goes into 9 3 times. Then I'm going to take and look at the other two fractions. And is there a common fraction, a common factor between 4 and 16? What? 4. So I divide 4 into 4, it goes once. 4 into 16 goes 4 times. And so I'm left with 4 times 3 over 1 times 1. 4 times 3 is 12 over 1. So that's just 12. Now, the reason we say Jimmy Neutron is because if you just did this, you'd have the little Jimmy Neutron symbol. Okay, and a lot of classes in the past have been able to remember cross-canceling by doing the Jimmy Neutron. Okay, so now let's relook at the problem. 16 times 3, 16 over 3 times 9 over 4. Now, I want to show you why we can cross-cancel. Okay? 16 times 9 and 3 times 4, these two are equivalent to each other. Okay? Now, what I can do is this. I can take 16 and I can write it as a prime factor. 2 times 2 times 2 times 2. Then I can take 9 and write it as a factorization. That would be 3 times 3. Over, you want to stop, Brittany? Over 3 times 2 times 2. Okay, 2 times 2 is 4. This is why I can use cross-canceling. I can cross-cancel my 2's. I can cancel out my 3, leaving me with those two 2's and that 3 which is 2 times 2 times 3, which is 12. That's how I get the 12 by cross-canceling that I did up there with the Jimmy Neutron. That's why we can do it. You don't have to show it this way. Okay, but I have had students in the past that like that way better because they can see it better. Okay, but it doesn't have to be done that way. It's whatever way you see best, but you have to be good at prime factorization if you're going to do it the second way that I did it. Nick?
How did you get
2
12?
times 2 is 4 times 3 is 12.
Oh.
Right here.
Okay.
And right there. A whole number? Not always, no. Now, if we go back up to our original problem, what is 5 times 2? 10. So is 12 close to 10? Yeah, it's pretty close. So that's a good answer. That's a logical answer. Now, if I'd have gotten 24, then obviously you did something wrong, because it's got to be close, because right here, our next number would be 6 times 3, right? That would be the next whole number you come from 5 1/3 to, okay, what would be 6 times 3? 18. So really, your estimate for this answer would be 10 to 18. Okay, and so that would give you an idea, okay, does my number fall in between that? Yes, it does. So that's a logical answer. Doesn't mean it's right. It just means at least it's logical. Okay, Quade. Will it ever be where you just multiply straight across? It can be, yes. 2 times 2 times 2 times 2 is 16. I just prime factored 16. And then I prime factored 9, 3 times 3. Yeah, that's where I got those. What? Talk to me. Where did I find the what? The estimate? By looking at the whole numbers back up here. Looking at this whole number here, 5 times 2 is 10, okay? And then 6 times 3, if you rounded them up, 6 times 3 would be 18. So that would be the highest and the lowest possible estimate that you would have. That's the lowest number that you could have and it be logical, and that's the highest number that you could have and it be logical. 6 times 3, because if I round 5 1/3 up, it would be 6. If I round 2 1/4 up, it would be 3. That would be my next whole number. So I'm just trying, when I did that, I'm just trying to get a whole number estimate of what my answer logically should be. So if that was like 10 1/3 and 12 1/4, well, my logical estimate would be 10 times 12, which would be 120. And so you'd want your answer close to that. Now, I'm going to do another one that will give you a better look at that. All right, let's do another mixed number. We've got 2 2/5 times 6 2/3. Okay, so the first thing is to change it to improper fractions. So step number 1, change it to improper fractions. So 2 2/5, I would take 2 times 5, which is 10, and then I would add 2 to that, which would make it 12. And that would be 12 over 5. So that's my first improper fraction, 12 over 5. How did I get what 2? That's the denominator. That right there, that is that number right there. No. Once again, 2 times 5, which is 10. That's where I get the 2 times 5 is right here. 2 times 5. So if that had been a 3 out in front, it had been 3 times 5. Okay, we'll be a little less dramatic with your movements over here.
What would you do if, like, the denominator is the numerator and the improper, the denominator is the larger than the numerator?
Can't be. If you do the correct improper stuff, if you have a mixed number and you do the changing a mixed number to an improper fraction properly, the numerator will never be smaller than the denominator. It's impossible. All right, now the other one is 6 2/3. I got to change it, so I'm going to go 6 times 3. So 6 times 3 is equal to 18. Then I'm going to add the 18 to the 2. So that would be 18 plus 2, which is 20. And that's 20 over 3. So this is 20 over 3. Now, we look at cross-canceling. Okay, is there a common factor between 20 and 5? What?
4.
No.
Wait, no,
5 is the common factor. 5 goes into 5 one time. 5 goes into 20 4 times. Is there a common factor between 3 and 12? What? 3. 3 into 3 once. 3 into 12 4 times. So that leaves me with 4 times 4 on top, 1 times 1 on bottom, which is 16. Once again, that 4 and that 4 is what's left on top. This 1 and that 1 are what's left on bottom. Now, these just happen to all be whole numbers so far. That's not always the case. You're going to end up with mixed numbers. Okay? Now, back real quick before I answer Lily's question. If we look at 2 and 6, what is 2 times 6? 2 times 6 is 12. And if I increase this to 7 and this to 3, 3 times 7 would equal 21. So my estimate is that my answer needs to be between 12 and 21. Is 16 between 12 and 21? Okay, then that is a logical answer. Doesn't mean it's necessarily right. It just means it fits with that problem. Okay? Lily, what was your question? The 4 and the 1? Hang on. I divided 20 divided by 5, and that's where I got that 4. And I did 3 divided by 3, and that's where I got that 1. No, I want your name need to be on the worksheet, both names, and you need to put them in the basket on the desk before you leave. No, the way I got the 20 is I took 6 times 3. I took the 6 up. I took the 6 right here and multiplied it by that 3.
How'd you get to 16?
4 times 4. 1 times 1 is 1. Okay, so you have 16 over 1. 16 over 1. Anything over 1 is just that whole number. Okay? No homework, no. We'll finish it up tomorrow. We will do something in class. We'll have a quiz in class. But we're not having homework that you're going to have to do after Thanksgiving.